Now let me introduce our speaker, TIM HENG. TIM HENG has 15 years experience, and he is a director of Sunprod and also the organizer of this conference. TIM has developed and reviewed financial models across a range of industries and sectors through Australia and internationally. Now, his session is about 10 things you're not doing to make the most of Excel.
All right, thank you. So good morning, good afternoon, or good evening, wherever you are around the world watching this, whether you're watching it live or whether you're watching it from the comfort of your living room computer after the fact. Thank you to Enhiki for introducing me. My name is Tim Heng. I'm one of the directors of Some Product, and hopefully you've been enjoying a whole bunch of really great videos and presentations over the last, 16 hours now. So today's session, my session today, was going to be about 10 things that you're not doing to make the most of Excel. And then when I really thought about it, a lot of people are actually doing a pretty good job about working in Excel. So I really culled it down to maybe 4 really good things that you're not doing to make the most of Excel. And then we can talk about a bunch of other useful tools in Excel that you may or may not be using right now at all. But the first 3 or 4, we're really focusing on a couple of tools that you might be using day to day, tools like index, like data validation, like VLOOKUPs and so forth, and trying to make the most of them. So being able to take advantage of them in ways that that you wouldn't normally know how to use them. Now, this session is probably going to be about 40 minutes or thereabouts. I can probably extend it. Luckily, as one of the organizers of the event, I've got colleagues who are helping to control what the event is doing in the background as well. And so I trust that they're going to be able to jump in and set some interesting challenges for me to try and solve as well. I can see them grinning in the background thinking, okay, what am I going to set them up for? Oh dear. Yes, Talia, I'm more than happy to drag you into this and to have you challenge and give us some great ideas to try and work through. Also, I trust that they'll be looking after the Q&A as well. And so if you do have any questions and you're asking that and you're watching live, please feel free to use the Q&A and ask questions. I'll try and answer them. Hopefully the team will be able to sort of send them to me in a way that I can sort of view and respond at the end. If you're watching this after the fact, that's fine as well. Please feel free to drop a note in the comments and hopefully we'll be able to respond. So without further ado, let's take a look at some of these things. So I've created a list of items over here. We've got things like index, we've got data validation, approximate matches, trying to generate a top 5 sort of table. And then depending on how much time we have, we can talk about all the other really cool tools in Excel, like Power Query, Power Pivot, using forms, tables, and so on. So there's a range of things that we can talk about, but I really wanted to focus on the first functions and features that you might be using day to day. So let's start off with index. Index is one of these classic functions that we use to look things up, right? We see that classic combination of index and match when I'm searching for a specific value. And so if I was to look for accounting in this list, maybe I might do something like an index, looking through, let's say the salaries. And we might find where the accounting salary or the accounting label matches up with the department. And that will give me the first item in accounting for looking up the salary, right? Whoops, what have I done? There we go. The bracket on the end. So basic index match, everyone generally knows how to do this. Search for accounting in this list and it'll match it up and give me the appropriate value. Now, the thing that I've tried to do here is spin it around a little bit, because the question that I'm trying to answer is, for the accounting department, what are the total on costs? And so the on costs are this column over here, column D. Now this can be solved with a fairly basic SUMIF function, right? I can do SUMIF, where I'm looking through the department range. I'm trying to find the accounting department in this range, and I'm summing up all of the on costs that are relevant to this. And that's all well and good. Basic SUMIF function, let me pop this on the right-hand side. using SUMIF to pick up the on costs. So the challenge here then is, how do I set it up so that if I had an input, so instead of looking up on cost, maybe I can look up the salary instead. And what we see with the SUMIF is that in the formula itself, the on costs column reference is baked into the formula. And so we need to find some sort of way to make this reference a bit more flexible. Now, traditionally, I think the way that a lot of people have done this is using some fancy some product type function, because some product is the answer to so many different problems. In fact, that's why our company is called Some Product, because it was just the answer to all of these challenging things that you might have had to do. And so you could use some product in a way that allows you to, say, for example, look through the list of departments where that's equal to the accounting. This is something that I'm doing on the fly, so I don't know if this is going to work. We'll find out in a second. We might multiply that by something where we're looking up the salary. Let's pop that into brackets and then multiply all of that by the actual set of values as well. And this should hopefully give me that 400,000. Same result here. And if I switch this from salary to on cost, you'll see that updates. If I switch it to package, you'll see that updates. But you'll also see that this is a really long formula. So if I move that over here and just scroll across to the right a little bit, we're doing a lot of things in this sum product. We're searching through the headings, we're searching through the column, and we're cross multiplying all of those values against each other. So sum product is not necessarily a very fast function in this regard. Secondly, it's also a really long function, which is less than ideal. So this is where index comes in. What people know when they're using index is that if they want to find a specific item in this list, say if I'm looking in this table over here, index table, we get options for a row number and a column number. So if I were to pick row number 5 and column number 4, that will search through the list and it'll find 1, 2, 3, 4, 5, this second marketing option. It'll move 4 columns to the right, 1, 2, 3, 4, and give me the result of 25,000. So this is your classic index and how it works, right? Where we're choosing a row and we're choosing a column. What a lot of people don't realize is that if you put 0 in one of the row or the column parameters, you'll actually get the entirety of the row or the entirety of the column. And so if I were to switch this around and say, give me row 0. Now, there is no row 0 in a table, but row 0 will actually present me all of the rows. And so this is now column 4 for all of the rows. And if I switch this to column 1, this will give me the result of column 1 for all of the rows. Likewise, if I spin this around, I can say, give me row number 5 and give me 0. So give me all columns for row 5. And here what we'll see is this row 5 marketing 42,000, 7,350, 25,000 reflected here because I'm using this column 0 formation. So row 5, column 0. So with that in mind, we can combine these two concepts, right? We can use the SUMIF concept where we have summing if the department is accounting, but instead of looking specifically at the on-cost column, maybe we can use index 0 to search for a specific column we're looking for. And that's what we're doing over here. Let me put this formula up. Oh, keep clicking multiple things. Formula on the screen here. So what this formula is doing, it's using a SUMIF. So as we did before, SUMIF the department is equal to accounting. But then the second part of this index function. This index function looks through table 1, and it's going to pick up all the values in table 1, and specifically because I've got a row value of 0, it's going to select an entire column. What column is it going to choose? Well, that column is going to be based on where it can find the package name in the list of our headings. So what we're doing effectively is we're saying match package with the headings to give me column number 4. So index is going to give me all the values in column 4 because of that row number of 0. And therefore the SUMIF is going to sum through to find all of the accounting items where the package column is, or where we're aggregating the results of the package column. So index 0 is a really nice trick that we can use to refer to entire columns or entire rows in order to help us aggregate our data set. All right. Now, this is the point where I would normally stop and ask, are there any questions? I appreciate that this is a live event and a webinar, so naturally there's going to be a little delay in when people have any questions, but I'd like to invite people again. If you do have any questions, please feel free to put them in the Q&A chat. More than happy to try and answer them in due course. Okay, so for the second tip that we're going to talk about right now, we're going to be talking about data validation. Now, let's move on to this data validation sheet. And when we're here, I can see something has greeted me. It says, hello, I'm Casper the friendly ghost. Let's be friends. Zooming in doesn't make that bigger. Frats. Okay. So, hello, Casper. I'd love to be friends. Let me move away, though, and let me try and work on something else. Except as I move away, Casper is following me around. There you go. That's a little bit silly, isn't it? Who is this Casper? Well, this is all themed in preparation for Halloween. If you're watching this live, it's currently the 11th of October here in Australia. UTC, it's ticked over to the 11th of October, which means that Halloween is going to be in about 20 days' time. So I thought I'd dress up this data validation in a Halloween theme for us. Now, Casper is following me around, but how did Casper get here in the first place? When we're working in Excel, we often have a need to provide some sort of message to people to act as guidance. Sometimes this might be in the form of a comment, right? So Shift F2 allows me to create a comment or a note that I can use, as they're called now, to let people know some instructions. This cell is for inputting X data. So when you leave an old school comment, or now they're called notes in Excel, you mouse over it, it gives you the little red triangle to tell you there's a note here. But it requires you to actually sort of mouse over that cell and have it, I guess, have it be the focus of what someone is actually doing at that point in time. If I just simply select that cell, it doesn't actually do anything. Alternatively, I could set up that note so it's always visible. The problem with that note then being that, well, then I can't see it, right? Then it's blocking other things on my spreadsheet, and that could be a problem. So I'm going to hide that note again. We're going to acknowledge that there a note is there, and that we can click on it and mouse over it and view what it is. But there are better tools that we can use in Excel to explain how to use different parts of your spreadsheet. And Casper is going to be my lovely assistant here. So the way to enable Casper, who is going to be my new Clippy 2.0, Casper is available through the data tab and then the data validation option in the top right-hand side. So when you click on data validation, normally you've got the ability to restrict what people's inputs are going to be. So we might restrict people to only whole numbers that are between, say, 1 and 12, or maybe decimal numbers between 0% and 100%. The more frequent usage is where we provide people with a list, where we can say, choose any of the values in this list. Now, in a lot of cases, we're going to find that these data validation criteria are not necessarily easy to understand for people. So suppose I've got some input percentage here, let's say an interest rate. And I'm saying that this interest rate, let's mark it out with a little input style. This interest rate needs to be between 0% and 12%. So I could set up some data validation here, data validation, that says, allow me to have a decimal number that is between a minimum of 0 and a maximum of 0.12, being 12%. Okay, between 0 and 12%. So now if I were to enter, say, 10%, everything's fine. If I were to answer 5%, everything's fine. If I were to answer 15%, then I get the error that says this doesn't match the restriction. Now, this particular dialog box doesn't really tell me much information. It tells me that I've not met the data validation restrictions. So if I'm designing a spreadsheet, it'd be useful to be able to give people more information about how to work around these data validation rules. So if I go back to data validation, I can switch to the error alert tab, and this allows me to customize that message that I want to put through. I might say error, interest rates need to be between 0% and 12%. Please try again. Okay, so now when I try and enter 15%, I get an error that says, this is what the parameters need to be. Try again. Okay. For what it's worth, in the data validation section, this error alert can change. And so the basic data validation stops you from entering that value. So it's essentially retry or cancel. Those are your options. If you switch it to warning or information, the pop-up that comes up is a little bit different. So let me just switch it to warning quickly. If I were to type in 15%, I get a warning now. It doesn't force me to retry. It actually allows me to accept the 15%, and I've been warned that it's outside the tolerance, and that could be a problem, but it's not something that specifically stops me from entering the 15%. So that's the difference between the stop data validation and the warning data validation. If you know that we're just that this restriction is simply guidance, then you might want to put a warning instead. If it's something that is actually restrictive, then you would want to use stop instead. There is actually a third option in here as well. The third option is information. And information, if I were to, let's put in 15% again, it simply says, this is what you should be doing. And it doesn't actually give you the option to retry as such. So stop would cause you to retry it. Warning gives you the option to say, yes, I want to keep it, or no, I'd like to try again. Information simply just tells you that you're outside of tolerance, and that's it. It's not going to prompt you to really make changes to it. So with that in mind, these are the three different sorts of data validation that you could use depending on the sort of message that you want to send to people, to give them guidance on how to update their values. Now, it's a little bit passive aggressive to let people enter in whatever they want, like 15%, and not tell them that they've made an error until they actually make the error and then drop the message in place. So what we're going to do instead is put a message into our data validation, which you'll find in this input message. And the input message is where Casper's been hiding. There we go. Hello, Casper. Instead of this input message from Casper, what we can say is, interest rates. This input needs to be a value between 0% and 12%. Full stop. And now when I click on the cell, it gives me a message that says this input needs to be a value between 0% and 12%. It's a user-friendly message. It documents what the valid values of the cell are, and it doesn't sort of irritate people by seemingly allowing them to enter whatever they want, and then subsequently giving you the wrong answer. So input messages are really great ways to pop up a message to let people know what's going on and to give people guidance without sort of letting them make mistakes and run into errors themselves. The other thing it's particularly good for, really great for being able to prank your friends and your colleagues if you want to turn their spreadsheets into haunted, ghost-filled cells. All right. Much better than the other tip that Liam likes to do, which is the best tip of all time, putting data validation that puts a restriction along the lines of whole numbers that are equal to blah, 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 with an error message that says something along the lines of critical error. critical hard drive error, all data will be deleted. And of course, the cherry on top at this point mustn't be press any key to continue. And so when people run into this particular error message, they might get a little bit of a shock of their lives. And so, you know, trick or treat, right? And all in the Halloween spirit. All right, data validation, good fun. So let's move on. I don't think there are any questions. So why don't we move on to the next topic we have here?
Yes, Tim, there are some questions in the chat.
Fantastic. What questions do we have?
Yeah, the first one is, what are some lesser known data visualization techniques in Excel that enhance the presentation of data?
What are the lesser known data validation techniques?
Yeah.
All right, so if we take a look at some of the data validation, so I guess most people will tend to use list and whole number and decimal, like those are the really common ones that people use. I do see people using date sometimes. If something needs to be between start date or end date, a value has to be part of this year, right? So I might have something here that says link to say the 1st of the 1st 2023 and the 31st of December 2023. And so if I have an input date in these cells, I might say has to be between the start and end here. Let's turn this into an input so I can remember where the data validation is. And so if I enter today's date, 11th of the 10th, 2023, that's perfectly valid. If I change that to 2024, then I get the error message to tell me that it's not in the date period. Another really useful one that I find, especially when you're doing form entries, when you're creating data validation for a form, I might have, say, a name input. Now, name's one of those weird things where you could have a really, really long name, but when databases aren't set up to take 50 characters or 30 characters, however long your name might be, there are some problems. So one really nice form of data validation that you might use is the text length. And so we could say that the text length has to be less than or equal to, say, 30, or let's make it a smaller number, 12 characters, okay? Actually, let's also put in an input message that says all inputs must be less than 12 characters, less than or equal to. Less than or equal to 12 characters. Now, this is a really useful tool because it means that if you're entering a value, you know that the value is going to be valid. So if I enter A, B, C, D, E, F, G, H, I, J, that's going to be 10 characters, and that's a valid entry. If I were to enter a few more characters, J, K, L, M, that's going to be 13 characters. And here I'm going to get an error message that says we're going to breach that 12 character limit. Now, this is really useful when you know that the field that you're entering in is going to be used and dropped into a database that has that shorter text string length. So especially things like name fields, account numbers, project codes and so forth, they're usually a very specific length, like 6 characters, 8 characters, 10 characters, and so on. So having this sort of text length data validation is a really nice way to provide that extra restriction so that people can't enter things in your form that subsequently don't work in the database afterwards. Finally, I guess the last option for data validation is the custom data validation. And so let's move to a different cell, custom data validation. Here you can just type in a formula that will provide a rule to say, is this value going to meet the formula restriction? Does it give you a true result or a false result? And if it gives you a true, then everything's fine. If it gives you a false, then there is the problem, right? And so we know that we can do between values really easily with interest rate, with the interest rate data validation. Here, maybe I might do a setting that says, check if the formula is either less than 0%, or that it's greater than 0.12 instead. So in this case, the restriction that I'm putting in, it has to be outside the range, so not between the range. And so if I enter a value of 5%, it's going to fail. But if I enter a value of 15%, then it's perfectly fine. So as long as you can set up a formula rule that points to that cell or even other cells next to it, you can set up some rule that will result in a true or a false result, and that will either allow the results or allow the cell that you're entering in, or not allow it accordingly based on the true or false. So hopefully that answers the question. Thank you, Talia, for passing that on.
Hi, Tim.
Yes, and Hiki.
We have one more question. The question, are there any limitations or potential pitfalls associated with data validation in Excel that should be aware of?
Any limitations of data validation in Excel? Yes, so data validation in Excel are guidelines more so than absolute protection, right? You are never going to absolutely protect your spreadsheet. And here's essentially the reason why. If I were to have a date and I find I'm trying to enter the 11th of the 10th, 2024, that doesn't work. So I might come over to a different cell. Let's find a cell over here, 11th of the 10th, 2024, and I'm going to copy and paste it over. And that's going to remove the data validation and work around the problem. This is less than ideal, let's be honest. So anything that you do with data validation, you can effectively bulldoze the data validation by copying and pasting over it, which is a bit of a problem. How do you work around this? I mean, you can try to do better worksheet protections to disable copying and pasting on the sheet. Yeah, it's kind of limited. You know, I could very easily take this data validation and simply go to home, clear the data validation to get rid of it, and then type in 11/10/2024. Like, there are so many ways that you can circumvent data validation that it's not going to be bulletproof. All you can reasonably rely upon with data validation is that it's going to be how do I say? It's going to be guide rails for people who are using the spreadsheet, not hard and fast actual sort of super sheet protection. All right. Give me 1 second. Okay. Any other questions here? If not, then let's move on to the next bit. Let's take a look at the approximate match. So most people, when they're putting together a VLOOKUP or an index match or an XLOOKUP, they will generally use an exact match. An exact match is one where we're searching for a value, say this 11th of the 10th, 2023, and we're going to find it in the specific data sets here. So what are we looking at then? If I were to do a VLOOKUP here, and I'm going to use VLOOKUP specifically. I'm not a fan of using VLOOKUP, but I know a lot of people are, and they find it easier to work with. So I'm going to use VLOOKUP very quickly right now. If I were to VLOOKUP equals VLOOKUP, the 11th of the 10th, 2023, in this list, where I'm looking up the closing balance, number 3, then it's going to give me a value of, sorry, I forgot to do an exact match. It's going to give me an NA result. Excellent. Now, okay, this is, let's see, this is essentially going to give me a problem, right? Because if I'm trying to work out what is my closing balance at the 11th of the 10th, and the 11th of the 10th is not an item that's actually in this list, then yeah, we're going to have a bit of trouble. So what do we do instead? Well, if we think about it conceptually, what are we actually trying to do here with this closing balance? We're effectively trying to say, find the balance that sits at the date 11th of the 10th. Now, if I look through this day by day, on the 8th of the 10th, I've earned $10. I now have a balance of $110. And you know, on the 15th, I earn another $20 and my balance goes up to $130, which means theoretically my balance is $110 all the way until I hit the 15th of October. So if I choose a date somewhere between the 15th and the 8th, then this is going to effectively revert back to the date of the 8th to say what my balance is at that point in time. And this is essentially how approximate match works. So here's my function using a basic VLOOKUP. I'm not trying to make this any fancy thing. I'm not going to go into the VLOOKUP versus index match versus XLOOKUP or anything like that. Just going to use VLOOKUP because it's the simple formula that everyone understands. The key thing that I want to highlight here is this true value on the end. Most people will choose false. But for this specific instance where we're trying to find, we're trying to look up a date that falls between different values, we need to use true. And so what this is doing, this is going to look through and find where does the 11th and the 10th sit in this range. It's going to recognize that the 11th and the 10th sits somewhere between the 8th and the 15th. And then it will pick the biggest value that is less than the 11th. So in this case, the biggest value that's less than the 11th is the 8th, which gives me 110. If I were to move forward a week, if I go to the 18th of the 10th, 2023, it's going to search for the biggest value that is less than the 18th. And so if I look through this list, the biggest value that's less than the 18th is the 15th of October. And so it's going to give me the corresponding 130. So there's my formula text. We'll put it on the right-hand side. There's my approximate match. Now, most people, when they use VLOOKUP and index match, they just immediately discard the possibility of trying to use approximate match. But approximate match is actually really cool. It solves a lot of problems that you don't normally run into. So say if I had a series of grades, A, B, C, C, D, and E. And these grades might be worth anything over 75, anything over 65, anything over 50, anything over 40, and then anything over 0, right? This is the grade range that I might be looking at. 74, 49, 64, 49, and 39. Okay. What I could do here, if I had a grade of, say, 70, a grade of 70 doesn't really help me with this, right? If I do an index match on this, searching through here to try and look up the correct value for the grade isn't going to work, you know? Let's do a match over here, equals match 70 in this list. That's actually pretty hard. I can't get this to work necessarily. Oops, what have I done here? I have done too many steps. There we go. The match is going to give me an NA result. If I try and do a less than or approximate match, that's also not going to work in this case. And the reason it's not going to work, or it's going to give me a false or a weird result, is that when we look at approximate matches, specifically in this, choose the biggest item that's less than a certain value, the data needs to be in strictly ascending order. So if we go back to the VLOOKUP and we look at the true result or the true option, you'll see the tooltip here. It says approximate match. The values in the first column of table array must be sorted in ascending order. And this is the thing that most people don't realize. And so they try and apply the approximate match on data sets that don't work. They realize it doesn't work, and then they just give up on it. They say, this is useless, we can't apply it. And it's simply that they haven't read the instructions or they've not applied it to an appropriate data set. In this particular instance, what we can do is, instead of using a match type of 1, which is the approximate match, there's actually an option here for a greater than match. So instead of looking for the biggest item that is smaller than the lookup value, this is going to look for the smallest item that is bigger than the lookup value. So in this case, if I apply that check, and instead of looking at the lower boundary of the grade, I look at the upper boundary of the grade instead, that's actually going to work. So a 70 is going to look through this list. It's going to realize it's somewhere between 64 and 74 and revert to the 74 value, grade of the second option here, which is very kindly between 65 and 74. If I were to search for 85, 85 sits between 100 and 74. It's going to give me the larger of the values, which is a grade of A, which falls between 75 and 100. Now, once I have this, I can wrap my index around it to give me the corresponding actual grade that I need to match up against the score. So this is using the match approach, where I'm not using an approximate match where it's less than, I'm using an approximate match that is greater than instead. Now, the other way I could have done this is using an XLOOKUP. Now, XLOOKUP has a couple of really cool tools, which are, the fact that it defaults to exact is one of those really cool tools. But say if I look up the grade, I'm looking up the grade in this list, and I'm looking up the corresponding resulting sort of letter grade. I'm going to skip the if not found. What we're going to do here is search for the exact match or next smaller item, which is the approximate match that we get from VLOOKUP. Okay, I'm going to choose this, close brackets, and that's going to simply work. So let me just do a quick formula text to show you how this is working. Let's switch it to 73. 73 is going to give me a result of B, even though the data is not in alphanumeric order. And that's because XLOOKUP is really smart. XLOOKUP doesn't actually need your results to be in alphanumeric order in order to work. It can run that approximate match without forcing the data to be in a certain order. And that's really cool. Like that's one of the reasons why you would use XLOOKUP over tools like index match and VLOOKUP, because it's more robust and it's less likely to come into errors when your data isn't quite in the format or isn't quite as clean as you expect it to be. Okay. So don't discount approximate match. It is a really useful tool. Would try and use it when you get the opportunity to. All right. Talia, are there any questions that have come through that we need to answer?
I think.
Sorry. Yep.
Yes, we have 4 questions.
Okay.
So the first one is from Harry Smith. How XLOOKUP deals with duplicate?
XLOOKUP deals with duplicates exactly the same way that all of your index and matches and so forth deal with duplicates. It picks the first value, essentially. If you don't want it to pick the first value, there is a search mode that allows you to go last to first instead of first to last, in which case it'll pick the last value instead.
Okay, great. The next question is, what are some less known data visualization techniques in Excel that enhance the presentation of the data?
Lesser known data visualization techniques that enhance the presentation. It's probably outside the scope of this particular session, but I mean, using tools like slices, for example, to make it easier to interact with your charts, using data validation to control chart data, in order to, again, increase that interactivity that you have with your charts. Other tools, like you could use hacks for charts, such as like creating bullet charts in Excel by having 2 data series and having a background series and a foreground series, right? Those are some things that you could use to enhance the presentation. One that I like, I guess, let me just use a random sheet here. If I have values of 1, 3, 5, 7, and then I have values over here of 4, 8, or 4, 7, 10, 12. If I were to chart these 2 things in 2 separate charts, those scales are quite different from each other. But say if I want them to be on the same scale, one thing I can actually do here is have an extra item at the bottom that is the maximum of all of these values. Let's do the maximum of all of these values. And so now when I chart them, the scales are going to be exactly the same because the biggest value is aligned between the 2 charts. And then all I need to do is take that last value and make that invisible. So, oops, let's make it no fill. That's not what I want, not automatic. Fill, no fill. Oops. And I keep clicking on the wrong thing. Let's try again. No fill there. And over here, let's make it no fill. And so now I've effectively got 2 charts that are the same scale, and we've just got a hidden axis or a hidden column somewhere that's essentially forcing it to be the same axis. What you can actually do is have this max value sitting over here instead. Let's adjust this around a bit. If I were to make this on 2 separate series, I can plot that second item on a different series. So let's change the chart type, put the series 1 on a secondary axis, and then I can make that invisible. But that secondary axis or primary axis, maybe it is the primary axis that I need to put it on. But if I make that a stacked, well, there is a trick that you can use as long as the items are different chart items. There we go. That's what I'm looking for. No outline. So this will effectively give me a chart with the raw values that I want, but that hidden series behind that can't be seen but forces the chart to be a certain height. And so I think that's a nice way to be able to enhance presentation. If I've got 3 different expense categories, they all sit next to each other, then I want them to all be roughly the same height so that you can compare them side by side. All right. Any other questions? You say there was another question or 2.
Yes, there are 2 more. One is for Adder Haile. Is why do you think that users are overlooking some Excel functionalities?
Why are users overlooking Excel functionalities? It's quite simple. People overlook Excel functionalities because they simply don't know they exist. So a really great example of this would be index 0. If you've never had a need to put 0 in your index, then you're never going to actually know that it's going to spill out all the results for a column. Better yet, when you're thinking back in old school Excel, if you were to put in something like index 0 here, this would give you a hash value result instead. And that hash value would be because you have 4 different results across 4 cells, and old school Excel only let you have that in a single cell. So people have been sort of trained to only use the tools that they use, right? I was running a training course yesterday where I was introducing the notion of tables to people, capital T tables, where you can use your structured referencing, where you've got formula consistency for formula that you put in columns and so forth. Now, this is a tool, like tables have been in Excel for 16 years now. It's been a really long time. But if you've never been shown it before, then you simply don't know it exists, and it's not a case of overlooking it necessarily. It's that you've just not seen it in Excel, so you don't know to use it. And that's why I'm really grateful that we can put on events like this to make sure that people do have as much opportunity as they can to see different Excel functions and realize, hey, this is something that could be useful for me. Because if you don't see it, you don't know to try it out, and you don't know to look for it.
Great. And I have another question here is, which functions do you recommend to simplify complex calculations or data analysis?
Okay, that's a great question. I mean, to simplify complex calculations, I would say it's less a case of using specific functions, and it's more a case of just stepping out your calculations to make them easier, right? So a really great example would be something like your index and match, say. This index and match gets seen as a complex function, but in reality, you could probably actually split it out into 2 steps, right? You could have the match function being 1 step, and you can have an index function being the second. And so if you find that things are getting overly complicated, if you simply just step them out into step 1, step 2, step 3, step 4, what you'll find is that it's a much easier way to get to your answer. And that's a really nice segue into the last segment here. So apologies if there are actually other questions that we need to get through, but we need to. There's one last topic that I want to go through. And so we're going to see an example of trying to do something that looks quite neat, that you could probably do in a single cell, but we step it out so that it's easy to follow. Let me bring you to our top 5 example. Now, this data comes from the Analyze Data tool in Excel. So on the Home tab on the right-hand side, you've got this Analyze Data button that will look for insights and patterns and allow you to ask questions about your data. When you don't have any data on the page, when you click on this, it will actually invite you to try an example data. So if you want to play along with this particular example, you can click on Analyze Data, try an example, and that will give you this specific data set. So when we analyze this data, this can offer you different suggestions, different pivot tables, different charts, different pivot charts, as the case may be, but it also allows you to ask questions about your data. So I might ask, for example, what are the top 5 rating products? And that will tell me that helmets, locks, lights, tires, and tubes and chains are the highest average rating products, which is pretty cool. What I'm going to ask it again instead, though, is what are the top 5 selling products? Because that's the particular question that I've worked out for myself here. And so again, it's going to give me the highest sum of sales of these different products. Now, if I were to insert this as a pivot table, that's going to give me these 5 products. It's going to give me the total of these 5 products. But what it's effectively doing is it's filtering out all of the items that don't meet the criteria. And that's a problem, because I don't just want to see the top 5, I want to see everything else as well, just bunch it into an other category. So I've got a bunch of calculations on the right-hand side that help me do this instead. First of all, I've used a dynamic array to generate a unique list of products. So what are all of my different products, and what are the sales associated with those products? So unique list of products, SUMIF, this is going to give me a list of all the different products and the total sales. Then what I've done, I've sorted that list to give me the top 5, or give me the list from biggest to smallest. So I'm using the sort by function. So sort the list of products by the sales, where the sales are going to be in descending order, top to bottom. Then on the right-hand side, what I've used is a function called take. Now, this is one of the newer functions that have come out in Excel, and I say newer in the sense that these dynamic arrays have now been out for 3 years or 4 years or thereabouts. Take has really only been out for what, 12 months or so. But what take does, take allows us to point to an array and pick up X values. So I might choose 5 to give me the top 5 items. I could choose -5 to give me the bottom 5 items. But because I'm trying to work out a top 5 here, I'll just use a +5 number. Now, I know that all of the other items are going to be bunched under this other category. I know there's only going to be 5 items in this list, so this dynamic array isn't going to sort of spill out over this other category. So I'm happy to lock in an other here in this 6th row. And then off to the right-hand side, I'm just doing a very simple lookup. The XLOOKUP is going to look for these labels for the different products and pick up the sales amounts. Now, I'm being a little bit fussy here. I'm using XLOOKUP to pick up the results from something I've already created, rather than a SUMIF going back to the original table. And that's just because it's a bit faster, right? Instead of searching through hundreds of rows of data to re-aggregate the sales, I'm going to something I've created already and doing a quick lookup instead over 20, 30 items. So this top 5 all makes sense. This is pretty straightforward. But the other category we can generate by taking the sum of our sales minus the sum of our top 5 sales. And this is now a really clean way to be able to create a table that we can then put into a chart, we can put into a dashboard and use wherever we like. So take 5, picking the top 5. If I want to make this top 3, then I could just as easily change my hard-coded 5 to be a hard-coded 3, and this will now give me 3 sets of sales, and the last 2 will get bundled into the other instead. Okay. All right. those are all the things that I wanted to go through. We've got time for a few more questions. So if I could pass it back to our host to let me know if there are any additional questions that are being asked.
Yes, Tim, we have 2 more questions. The first one is, how does the index function perform when dealing with large data sets or dynamic data ranges?
How does it perform when dealing with the large data sets or large data ranges? I'm assuming that question is in relation to like speed and efficiency versus versus any sort of other, does it work or does it not work, right? Index is fast. Like index is pretty fast. The only function that's faster than index is offset. So you can very happily use index to refer to large data sets, and that's not a problem. To use it in this particular context where we've got the index 0 to select specific columns, if we think about what it's actually doing, it's doing a match on the headers, which is pretty short. We're looking up at one value across 4 items, and then it's just getting a range of cells that are associated with that. So yeah, very quick, I would say. Mm-hmm.
Great. And the last question is, hi Tim, is there any substitute for SUMIFs that allows arrays instead of range of references? I think index 0 works with SUMIF only when it's a range reference.
That is correct. SUMIF and SUMIFs they don't work with arrays, and so if I try to do something like SUMIF and then have a range X, Y, Z or something like that, it's not going to work, and I don't think there's any way it's going to work at the moment. My guess is that Microsoft would need to change the way that the SUMIF function works. And there's a few other functions in Excel that operate in a really similar sort of way where they need to have a range rather than an array. Like data validation is a good example of that. When you have a data validated list, you can't use a unique function, for example, to power the dynamic data validation. What you need to do is have a unique function that points to that spills out into a set of cells, and then you have your data validation point to that set of cells to get it to work. So there are just some things in Excel that at the moment aren't going to work when you have arrays as your input rather than your ranges. So with that in mind, then what I would suggest is use best practice and actually spell out all of your calculations step by step. Because when you do that, you're less likely to run into that problem because all of your interim calculation steps have their own ranges, and then we can use those ranges accordingly. Mm-hmm. Are we out of time, I think?
Yes, and also we have no more questions so far.
Excellent. Mm-hmm. Well,
thanks so much for joining.
Yes, thank you. Thank you for hosting, and thank you everyone for listening in. As always, I hope that you enjoy the rest of these sessions, and whether you're viewing live or whether you're viewing after the fact on YouTube, I hope you have a really great day. Thank you, everyone.
My pleasure. Have a lovely day.